So, welcome. My name is Anna Strahl, and I am a senior course developer here at Dataquest. And today in the Dataquest Project Lab, we are going to be analyzing a data set on helicopter prison breaks. And we're going to use Python as our tool of choice for this. As we get started here, if you do have questions for me about this project, please use the Q&A box instead of the chat box, because as you can see, our chat box is very active. And to make sure I see your question, Q&A is the best place for it. I did see one question pop in about, is this being recorded? Yes, it is being recorded, and the recording will be shared with you tomorrow via email in the same email you registered for this webinar with. So if you want to rewatch or if you miss anything, don't fear, it's available. All right, so to get started, just a quick introduction to myself. My name's Anna, and before I worked at Dataquest, I was a high school math teacher for 8 years, and I loved teaching, but I was ready for a change, and I was self-taught to become a data analyst. I worked as a data analyst for 3 years before getting to merge my two loves and my two passions of teaching and data to be a course developer here at Dataquest. So a lot of you are self-taught and working on a journey towards a career change, and this is some words of encouragement for you. Yes, you can do it. Stick with it. I believe in you. Now, let's make sure that this webinar is the right fit for you. This webinar is extraordinarily beginner-friendly. If you are just starting out with Python, meaning that you know variables, you know lists, you know loops, and some conditional logic, you're going to be able to follow along with every step of this project. However, if you do have a little bit more experience, maybe you've worked with pandas before, I have tailored a couple parts of this project to our more intermediate users. So if you stick around towards the end, we're going to do a kind of interesting comparison of lists versus dictionaries versus data frames for a question that I was asked on a technical interview. So we'll dive in. And you can see my Dataquest chat partner did share some links with you. You can follow along with the project in the Dataquest environment, which I'll show in a moment. And I also have a solution notebook that is a little different than the official solution notebook. So you can click the gist link there if you want to follow along cell for cell with this project. Now, just to make sure that I am tailoring my teaching to the audience we have, I just launched a poll asking you what your experience is. Have you done data projects before? Are you an expert? Are you a brand new beginner? And I also am asking about Jupyter, because this project will be in a Jupyter lab environment. And I am curious how much of a Jupyter tour I should give. So leave that poll open for a few moments here while I take a sip of coffee. All right, a few more people wrapping up their responses there. And it is looking like, I'm going to go ahead and end the poll now, so get your answers in. And it looks like, in general, our audience today is beginners, maybe a couple projects under your belt, but you're in the right place. And for those of you confident completing projects, welcome. I am very excited to share the technical interview question with you at the end, as well as give you a few tips and tricks that you may not be aware of. And for Jupyter experience, a little bit more split, pretty normal distribution there. And since the majority of people know the basics. I won't spend too much time on Jupyter environment, but I do have a feature that some of you may not be aware of. So let's dive in. We're gonna jump straight into the project here. The Jupyter tour, given our data analysis from our poll results, we won't spend a ton of time on, and instead we'll jump straight into importing functions, working with lists, and then pitting lists versus dictionaries versus data frames against each other. And then at the end, we'll do some Q&A. So in this project, we are going to be analyzing prison break attempts, people who have been in prison, who are trying to leave prison, not lawfully. And in particular, we're looking at helicopter attempts. A helicopter was involved getting a person out of the prison. And we're going to analyze two main questions today. What year did the most attempts occur in? And are there certain countries where this type of prison escape is more likely to occur? So let's dive into the project now. So I am currently in the Dataquest environment, and I am on page 1 of this project. If you're following along in the app, this is what you should see. If you're following along locally, you will need to ensure that you have this file, helper.py, downloaded in whatever environment you're using. You can use Google Colab if you're familiar with that, or you can use a Jupyter environment locally or here in the app. There's no data set because we're doing a pretty cool thing. We are taking data from a Wikipedia page, a live Wikipedia page. So the first thing we're going to do to make sure that we can stay beginner friendly here is very first line in our notebook is from helper import asterisk. And if you're familiar with import statements, this is going to import all of the functions in our helper file by name. This next line you do not need to write, but you may be familiar with importing things like this. And if you use this, you'll have to refer to the library using, in this case, our alias PD dot, and then you say the function name. So to keep our code clean, using the asterisk means we don't need to do helper dot function name. We just can use the function name as intended. So I'm going to go ahead and run this line, kind of import everything, and we can tell it's running and finished because there's a 1 in the corner. And now we're going to import our data. So right here is a URL saved as a string, and we're using a helper function here, data from URL. And if you are a strict beginner, this next part is going to be a little more advanced, so don't panic. But if you're more intermediate, this is kind of cool. The helper.py file is available for you to peek at. And this is intended to help keep your main notebook clean and provide some support for beginners. So you can keep this in mind when I work on projects with the Dataquest engineering team. Working with custom Python files like this and importing them into other Python files is something that happens all the time. So understanding how to interact with multiple files together is something that's kind of cool about this project. And here's the function that we're going to be referencing. Data from URL takes a URL parameter or argument, and here we are using some pandas behind the scenes. And we are reading an HTML file, and then we are converting it into a list. Am I able to zoom in at all? Thank you for asking. Oh. Okay. That's better. Yeah, thank you for that. I appreciate it. So If you're a beginner, don't worry about this. You don't need to understand this code. All you need to understand is that it is a function that you are going to put your URL into. And I really like that this project works with live data because the Wikipedia page is right here. This is a separate tab on my window, and we can scroll down and see the data set we're going to be working with. And I tested my data set yesterday, but because Wikipedia is live, there is a chance that something in here has changed since then because it is the internet. And maybe the the results today are going to be different. Who knows? And just to stay visual with their data, if you've done a lab with me before, I really, really enjoy just visualizing the data one step at a time. Here we are going to print the length of the data and the type of the data. And based on that, we're going to take a peek at the first 3 rows of our data. So I'm going to run this cell. So we can see our data set has 50 elements, and the type is a list. And now we're seeing the first 3 elements of our data set, and we can see each element is pretty lengthy here. Looks like there's a date, some type of location name, country, a Boolean, yes or no, and then a name and a long description. And by the way, this is a helpful character to know. This is a new line character, which separates each of our printed rows with a new line. For example, if I comment this out and rerun it, you can see it's harder to read because there isn't that like empty line in between each of the elements. And new line is this backslash and in string form. So for our data purposes today, the 2 questions we're asking, we do not need this very, very long description. So to clean our data set, we are going to remove that. And because this is not stored, and it's not a Pandas data frame, it's lists, because this is a very beginner-friendly approach. The data cleaning is less straightforward than it would be in Pandas. And if you do have experience with Pandas, I challenge you to try this project with Pandas methods instead. But for purposes of this webinar, we're going to stick to our basic Python skills. So what we're doing here is we are going to loop through every row in our data set. And just to make sure we're looking at the correct row and not dealing with any variable renaming of itself, we're setting the index to 0 because Python is 0 indexed. And we're saying that we're going to keep the row as is, all of the elements up to the last element. And this is going to cut off that final long description element and store it back to the data set as whatever index we currently have as our number. And then we're adding 1 to our index. So in the loop, it will store each row on the correct row. And visually, let's peek at that, make sure that our data cleaning stuff is working as intended. And we can see right away, yes, our first 3 rows, much, much shorter. We do not have a super long description for each data element. I'm seeing a couple questions in chat about if this will be recorded. Yes, it will be recorded and it will be shared with you via email tomorrow. All right, so the first question we're asking is what year had the most helicopter prison escapes? And right now we can see that our first column has a date in it, but it has more information than we need. And we're going to clean this so we only have the year. We know from our length function earlier here that we only have 50 elements. So keeping the entire date that goes back to 1971 isn't a valuable use of our analysis. So keeping just the year is fine. Oh, quick thing I'm going to explain here. Yes. Just for list slicing, what's happening here, and we're going to see this in almost every cell we do today, is this is taking our data set, and because our data set is a list, it is taking a slice, and it is slicing to include the 0. Python is 0 indexed, so this 0 refers to the first thing. It'll keep the first thing and go through to the third thing. So that means it's going to include the 0th thing, the first thing, the second thing, and cut off right before we hit index 3. So here is index 0, here is index 1, here is index 2, and 3 is the cutoff. Okay. So let's go ahead and just use the year. And here we are using another helper function called fetchYear. And this one is going to be intimidating if you are not comfortable with regex. And what's happening here is it's a very customizable search feature. That's what regex is at its core. And what we're doing here is we are going to return an integer version, because years are numbers. We're going to want it to be an integer. And this, don't panic, it's saying we're doing a fancy search for 4 digits in a row. So when there are 4 numbers in a row, I want that. And this means that we're looking at the first instance of 4 numbers in a row. And the reason this works for our purposes is because we are going to be searching for this. And where are 4 numbers in a row? Where the year is. Now, if regex is new to you, don't worry about the behind the scenes of that function. You will be able to use this without any trouble. So what we're doing is, once again, using a for loop. For every row in our data set, we are going to replace the first element that corresponds with the date. We're going to replace it with just the results of this fetchYear function, which should return just the year. And then to make sure it works, we're going to print our first 3 rows. And we can see pretty clearly our long date string has turned into just a year that doesn't have the quotation marks around it, which means it has converted correctly into, an integer. And if you do want to confirm that, we can do a quick peek at the type. What this is doing is it's looking at the first row, first element of that row, just peeking at the type of it, and we can see it's an int. Okay, so in order to see which year is most populated by helicopter prison escapes, we're going to visualize it. And to visualize it, we're going to want to see what years we have available to us. So I'm creating an empty list called years included. So what years are currently included in our data set, and looping through our data. This row is mostly just for keeping things clean looking in our project. The year is the first element of the row, and we are going to append that year to our list. So going through each row in the data set, pulling out the year and storing it in a dedicated list and printing it, because visualizing always good as you're going through steps in a project. All right, and we can see that our empty list has now populated with many, many year values. And it looks like We have years all the way from 1971 up through 2020. This list looks mostly alphabetical, not alphabetical in numeric order, but it's not perfect. There are a couple things missing. For example, I don't see 1972 here. I see that 1988 is included a couple times. And if we're wanting to visualize the frequency on a graph, these types of things are not going to be good for good visualizations. So we are going to see what the minimum year is and then the maximum year, and then fill in all of the years in between. So we basically are creating a year number line that doesn't have any missing values. And if you are following along with the official solution file that was provided from the project here, this is going to be a little different because I wanted to show my beginners in the group that you can do this. Oh, I did not copy the right thing. There we go. All right. So this list that we created, we are going to use a Python built-in function, meaning you don't need to import anything. This is already available as soon as you start opening up a Python environment. And we're going to look for the minimum value of our years included list and store it as min year, and same thing for the maximum value, and print them to take a peek. And we can confirm that 1971 is our minimum year and 2020 is our maximum year. And I do see a lot of questions coming into the Q&A, which is amazing. Please keep it up. I will answer questions towards the end of our webinar. So I'm not ignoring your questions. I just want to keep the workflow going. Okay, so now to create that number line of years, we are going to start with another empty list, and we are going to go from our smallest year to our largest year. But you'll notice here that I have +1. And the reason for this is very similar to our list slicing, where it cuts off. It cuts off right before this final element. And the range is another Python built-in function that will look at everything within a range between one value and another. So for year in this range, so for something in this range, we are going to append it to our list. And let's go ahead and print our list just to check. And I can see right away it's been successful because 1972 is present, where it was not present in our original years included list. And we can also see that the values that were duplicated several times, like 1988, we only have 1988 once here. All right. So now we're going to start creating a frequency table. And frequency tables, I see a couple people in chat talking about this could be a lot easier using X, Y, and Z. Yes, but the thinking behind these Python basics is what is going to help you become a better and more efficient programmer down the line, right? These are the foundational steps. And this foundational step could be done in one line of code with pandas, but the foundations are important. So empty list. What we're going to do here is create a list of lists. And here's our list, attempts per year. And within this empty list, for every one of our years, we're going to store it as a very short little list in our larger list. This one I think is easier to see and then explain. So I'm going to run this cell. And here we can see the logic here. We can see that 1971 is now kind of coupled with a numeric value 0. And we have done this for every year in our year range. And the reason we're doing this is we're going to start tallying. Every time we see a particular year in our data set, we're going to increase the tally that's coupled with it by 1. All right, let that sink in for a second. So we are doing the most complex loop of the project, and it is a nested loop, meaning there's a loop within a loop. And so for every row in our data set, we're going, one row at a time. So for the first row, we are then doing a second loop just on that first row. And while looking at the first row, we're going to look at a year attempt in our attempts per year. And we are going to look at the year, which is that first element in this couple. And we are going to check if the first element of our data row matches this year. Then we're going to increase the frequency of the year attempt by 1, because we know it happens at least once in our data set. And then it's going to loop through every single year and try to create a tally. And then it will move on to the next row and do the same thing. And this is not efficient. It is absolutely not efficient. A couple people in chat are asking, can we use value counts? Can we use unique? Yes. If you know those things, use them. But if you just know your basic Python, you can do some really cool data analysis here. And we can see that when we print our attempts per year list now, we see numbers populating. There was one attempt in 1971, 1972. Remember, we didn't see it. We didn't see it in our original year fetch year function. And yeah, there are 0 attempts. And then 1988, we know we had a couple instances of that, right? And we can see, yes, there are 3 instances populated into our attempts list here. Our data visualization is going to use a helper function here. And if you've done a project lab with me before, this line should be familiar. Anytime you're working in Jupyter and you want to have a chart visualized from Matplotlib or Seaborn, I think Plotly also you need this. Using %sign Matplotlib inline will render your charts how you expect them to be rendered. If you don't include this line, your results might be less predictable. And bar plot is not a built-in function. It is from our helper.py. And this one is kind of a mess to look at, I'm going to be honest, because it is creating a visual from a list, which is not a very common way to look at data in Python. So I'm not going to spend time going through this one, although I highly encourage you to peek under the hood here and see if you can figure out what each of these lines in the function is doing. And remember that you can always use some AI support to explain this for you if you're curious about the functionality. So let's see what we get. And we have a pretty nice looking bar chart. And remember that number line step we did to fill in empty years? This is why that number line was really important, because we start seeing trends where in the 70s, there were several years here where there are no data points. Is it because there were no attempts, or is it because the data wasn't recorded? I'm not sure. But we can see here in the 80s, there's a couple years where there were several attempts. So that could warrant further investigation. Are there more attempts because it was the same person in the same location over and over and over again? Or was something just interesting happening here? And then again, in the late 2000s, a couple more instances of years with higher attempt counts. So now that we have investigated the years, let's look at the countries. Which countries have higher helicopter prison escape attempts? And the methodology here is very similar. We're going to create an empty list. We are going to find the country from every row. And if we scroll back up to peek at our data, we have the year is the first list element, the prison name is the second, and the country is the third list element. And that's why we have a 2 here. And remember, this is a 2 because Python is 0 index. So 0, 1, 2. The third element corresponds with 2 here. And what we're going to do is for a row in our data set, if the country is not in our countries list that we're creating, we're going to add it to our countries list. And then I'm going to print the countries list to see if it has populated. And we can see here that, yes, we have several countries populated: Mexico, Ireland, United States, so on and so forth. So now we are going to go ahead and use a list method to find their frequency. And before I do this, I'm going to take a pause. In chat, please be kind to each other. This is supposed to be educational for everybody. That was my high school teacher voice coming out for a second there. I appreciate everyone being here, and we are all here to learn. And I have a personal anecdote to share here. Before I worked at Dataquest, several years ago, I had a friend reach out to me and say that her company was hiring a data analyst, and am I interested? And I said yes. But the problem was I hadn't been job searching, so I hadn't been brushing up on my Python skills. I had my Python skills, but it had been a minute, so I didn't remember a lot of the pandas methods, and I didn't have time to study. So interview rolls around, and the first question on my technical interview was to pull data and create a frequency table. And I panicked, deer in the headlights, because I knew there was a pandas way to do this, but I had forgotten it. So I thought I was lost. That was the interview. I didn't get the job, you know? But if I had kept my wits about me and remembered my basic Python skills, maybe it wasn't going to be the most efficient way of doing it, but I could have showed my thinking. And in a technical interview, that's what is being sought after. The interviewer wants to know how you think. And look at this, basic Python. There is nothing fancy here, nothing. Append is the only method being used, a nested loop. And we're going to create a frequency table. So I'm not going to spend a ton of time on this because we did a very similar method with our years a little earlier in the project. So let's take a look at what we get here. And yeah, we can see that we've looped through every row. We've checked to see if it is present in our countries, and then we're adding a tally to it. And we can see Mexico has 1 instance in our data set, United States has 8, France has 15. But here's the limitation of lists. Not only was it computationally very inefficient, it's not ordered. We can't easily see least to greatest. It's not pretty to look at. It's not in table form. So would this have done the job for that technical interview? Yeah, sure, but we can do better. So now we're going to see the same thing, but with dictionaries. And look at all this code we had to make, or all this code we had to write, several lines, cell 14 and 15 here, to create a frequency table using lists only. Dictionaries, this is all the code we need. It's about half the lines. And there's no nested for loops. which is the huge computational pool. So this is already going to be more efficient. And look, nothing fancy. There are more efficient dictionary ways of doing this, but I didn't want to include kind of fancier things like get and keys, because I wanted to have this just be strict basics of Python. And once again, we get a very similar looking frequency. Quickly, I'll talk through this. This time we're initializing countries as an empty dictionary. And for every row in our data set, we are pulling the country. And if the country is not in our dictionary, we are adding it to our dictionary as a key with a count of 1, because it is the first instance of the prison break attempt in that country. If it's already present in our dictionary, we're going to add 1 to the value count and loop through that way. And we can see, yes, we get the counts much quicker, but still not very pretty to look at, still not sorted. So now we finally get to the intermediate level, the one line of code that if I had remembered it, that would have been the entire question. We import pandas. Side note here, if you are creating a project to present to others, add to your portfolio, your imports should be in your top cell. But because we're just doing a quick little demo here, this is fine. So what we're doing is we're turning our data list of lists into a data frame using pandas.dataframe method. And this is just me being nitpicky. You'll remember, potentially, I'll scroll back up. You'll remember our original data set when we peeked at it didn't have any column names. But because we can access the Wikipedia page, we can see there are column names. Date, prison name, country, succeeded, escapees, details. So just for my sanity, and it makes the next line a little bit easier, I'm using the columns optional parameter and setting my column names in a list here. And very quickly, just peeking at the data, we can see already it's more visually appealing. If we were spending longer, we could clean up the index here, but that's all right. And then one line of code, looking at the country column, value counts. There's our frequency table. Now, my beginners, if you're not familiar with pandas, don't worry about this. You have 2 methods that work beautifully, and pandas is next up on your roadmap. So don't worry, you'll get here and then you'll understand that you have several ways to solve the same problem. And to answer our second data question here, what country has the highest frequency of helicopter prison break attempts? France. France and the United States, unusually high helicopter prison break attempts compared to other countries in this data set. Kind of interesting there. And that answers the 2 questions we set out to answer with this very beginner-friendly project, with a little side note here about efficiency and different methods. So project next steps. We answered 2 basic questions together with some very basic Python skills. But there are other questions you can answer with this data set. So I highly encourage you to pick one of these questions and try it on your own, and then share it in the Dataquest community. So for example, which countries don't just have the highest number of attempts, but are there countries that have high rates of success, meaning that the prisoner was able to successfully escape and were not recaptured? How many of the escapees, or does the number of escapees affect the success? For example, if 15 prisoners try to escape at once, is that more successful or less successful than if 1 prisoner tries to escape? And which escapees have done it more than once? And then maybe you can kind of have a little side history project there to see if there's any interesting information about those individuals. So at this time, we have about 15 minutes for questions, which is excellent. So I'm going to take a peek at the Q&A. Oh, we don't need the Q&A to be that large. There we go. So if you do have questions for me about this project, please go ahead and ask those questions in Q&A. All right, Karina asks, can I clarify what the +1 achieves in the code? Yes. All right, +1, there's a few places we used +1. So if you had one instance in particular, let me know, but what we're doing here, I'll do a quick, I'm just going to demonstrate what the +1 does. What we're going to do is, oh, I forgot my in. There we go. +1 is adding one count to a variable or a value every time that happens. So in this quick little example, we're just doing a couple iterations, and we can see even though num was originally 0, we're adding 1 to it and printing it. So we added 1, it prints 1. Now the value of it's 1. So when we add 1 again, the value is 2. And now the value is 2. So when we print it again, it's 3 because we keep adding and adding and adding. So in reference to our code, that's what's happening here, is if a country is already in our list here, what we're going to do is we're going to add 1 to the value. And this might get messy, but let's see. Trying to think if there's a quick way to visualize this for you. Yeah. It might get really messy, but we can kind of see what's happening here. So every time we're going through a row in our data set, we're adding the country. If it's not in our data, or not, if it's not in our dictionary, we're adding it and setting the value to 1 because that's the first time we see it. The next time we're going through our data, the next row is Ireland, so we're adding Ireland. The next row is the United States, so we're adding the United States, and so on and so forth, until we get to 1, 2, 3, 4, 5, 6, 7. The 7th row of our data is the first duplicate. And you can see the United States has gone from 1 to 2 because the United States is already present in our dictionary. The second time we see it, we add 1 to that count. All right. Okay, and another question here asking about, oh, I think I misunderstood the question, so hopefully this was valuable. But the clarification of the question was here. So the +1 here. This has to do with how Python references numbers. And actually, we can use this example. If I wanted 4 to be included in my output, I would need to tell it to look 1 past 4, because remember, there's a cutoff in Python that looks to the number but does not include the number. So it's, 1, 2, 3, 4, but the cutoff is before the 4. So now, because of the +1, we're including 4 because it's cutting off at 5 and not 4. And the reason we're doing that in our code, Where'd it go? Where'd it go? Here. The reason we're doing that here is because we want to ensure we keep 2020 in our data because it does represent a data point. All right, continuing with questions here. All right, Namita asks, can I explain the nested loop? Yeah, nested loops are conceptually, they can be tricky. So when I was learning loops, I spent a lot of time with print statements. So for example, if we're looking here, trying to, okay. This is gonna get messy, but we're gonna do it anyway. Might break my computer in the name of visualizing our process. No. And just to keep it clear, actually, I'm gonna label it row and label it year attempt so we can really keep track of it. Okay. And this would not be included in your final code whatsoever, but for visualizing it and kind of like understanding the behind the scenes. You can see here that now in our nested loop, and you are always welcome to do this on your own, it prints the row that it's looking at, and we can see it's looking at our first row. And then year attempt, it's looking at the year attempt, it's looking at the next year, it's looking at the next year. So what's happening is for this row of data, we are going through every year in our data set and checking if it matches that year information. And only after we've gone through every year do we go to the next row. And then for row 2, we go through every year and check. And then for row 3, we go through every year. So that's what the nested loop is doing. But you can see all of this that we're visually seeing right now is happening behind the scenes when we don't print it, which is why this is so inefficient. We don't need to do all of this. But if you're just kind of being scrappy and not able to utilize tools, maybe you can't look them up for some reason, you can brute force it. So Namita, hopefully that answers your question. Nested loops can be tricky, but print statements, for me at least, did help. Okay, and Karina, I think I hopefully addressed the +1 question. If I didn't, let me know. And Chukwebuka, hopefully I'm saying your name correctly. You notice my code has no comments. You are correct, and that is not best practice. My code should have comments if I am intending to share this code with anyone. And if I ever want to look at my code again, I should also be including comments for my future self. The number of projects I have gone back to from my past that I didn't write code comments in, and then I was kicking my past self because I had to spend way more time figuring out what my code did. Yes. Do as I say, not as I do. Please do write code comments to document your work. And if I were to include this project in a portfolio, for example, because it's in a Jupyter notebook, I would also highly recommend including some markdown cells for headers and explaining your findings. All right, looking through the questions here. Akram, can I post the questions to you? Hopefully I've been reading them as I go. If you missed one that you're curious about, let me know. And an anonymous attendee asked, can I talk more on the meaning of row 0? Yeah. So the question was about this. And once again, for teaching purposes, I'm going to make a dummy list. Nope, that's not list in Python. And what I'm going to do is just take a peek. What happens if, with a very simple controlled environment that I understand of this list, what happens if I look at the brackets with 0 here? And we see the value 1, which corresponds with our first element. And the technical explanation of this is Python is 0 indexed, meaning that even though as humans we count this 1, 2, 3, Python counts it 0, 1, 2. So if we're trying to look at the first element, we have to call it 0. If we want to look at the second element, we have to call it 1. And I had another question about how I seem so professional learning Python. Thank you. It's because when I was learning the basics, I would do things like this. I would say, wait, I don't quite understand what's happening here. Let me experiment with a very small visual that I can understand. So the number of print statements and times I crashed my computer visualizing nested loops, it was part of the learning process, and it helped me understand the behind the scenes. All right, I think I'm getting through the questions on time today, guys. This is great. Where do you add portfolio projects? So I actually did kind of a sneaky way of demonstrating this today, where my colleague shared my version of the project walkthrough code today in something called a GitHub gist. And for this level of project, I would recommend putting your code in a gist. And gists are very, very simple. If you have a GitHub account, go to gist.github.com. And if you click create a new gist, you can copy your code. And if it's a Python Jupyter Notebook, you're going to want to make sure it's not text, the IPy-NV file extension, so it renders correctly. If you don't include this, it's gonna look kind of ugly. And this will publish your gist. And so for me, for example, most of my gists are demos for projects like this, but this is public. If I wanted to show a potential employer what I've been working on very quickly, I could share my gist link with them and they could see all this code. And they can also comment on it. So I see someone's commented here. So thank you for that. And if you're looking for feedback from folks, you can also share it and they can comment. So I highly encourage sharing your work. I highly encourage sharing your work with others to get feedback, especially in the Dataquest community. It's great. As far as like larger portfolio projects, that's kind of beyond the scope of this webinar. But there are some very good Dataquest resources on that. So if you ping me in the Dataquest community and you would like those resources, let me know. And I can share them with you there. Okay, and I think a follow-up question about the row 0 back to the data set. Yeah, that was a very elegant piece of code, in my opinion. Here, right? Is that what's happening? No. Where'd it go? Where'd it go? Why am I not seeing it? Yeah, can I now apply this explanation of the row bracket to our data set? Actually, I think this was just a question about taking this concept back into the data set. And it happens in several places. So, for example, here, I'm going to take away this print statement. And we can see we're using this here. And we're looking at country equals row 2. So in order to visualize this, we're going to use two print statements. Print, we're going to look at the row. And let me label it. And then we're going to print country, which is the variable name we're giving to the row bracket 2. And if this is correct, we should see the country name for the corresponding row. And we can see our row is this, and our corresponding country is Mexico, which makes sense because 0, 1, 2, because of our 0 indexing, right? So print statements can be your best friend. What are some resources to write cleaner code? Oh, that's a great question, Tammy. And I think to write cleaner code, it really depends on what you're trying to do. For example, in this project, the fact that we used a helper Python file meant that all of these functions didn't have to kind of jumble up our main project notebook. Now, if you're doing a project to try to demonstrate your Python skills, keeping these functions in your main notebook would be fine. But if you're doing more production level work, these functions aren't needed for the end user to see, and keeping them in a separate dedicated file is a great way to clean up your code. All right, and looking at time, we are at time, and it looks like I've answered the majority of project-related questions. But if I didn't get to your question, please do tag me in the Dataquest community, and I would happily